So we'll now be discussing forward divided difference and backward divided difference and center divided difference. This method we will discuss is used to find the value of the slope at certain points. So for FDB, our formula is f prime is equals to f of xi plus 1 plus f of xi all over h. And for BDD, the formula is f prime is equals to f of x sub I minus f of x sub I minus 1 all over h. And for CDD, we have a formula for of f prime is equals to f of xi plus 1 plus f of x minus f of xi minus 1 all over h all over 2h. So we'll now have an example for these three equations so that can show how to use this method. So the example we will use is 3x squared plus 5x plus 5, and to we have to find the value of the approximate value of the slope at the point of xi is equals to 2 with an step size of 0.5. Wish to find the value of slope at the point of at the value of x is equals to 2. So first we will do is solve for the value solve for the value of f of xi. So value of f of x at point of 2 is equals to 27. So we will be using forward divided difference, center divided difference, and backward divided difference to solve the slope at the point of 2. So to solve for FDD, we will need to find the xi plus 1, which is 2.5. So applying this and then getting the value of f of x at 2.5, we have 36.25. So substituting this value to the formula, we have f prime of x is equals to 36.25 minus 27 all over 0.5, and we have a value of 18.5. Now let's solve this equation in center divided difference. So before center divided difference, let's solve this first by backward divided difference. So, by BDD, so we you will get firstly xi minus 1, which is 1.5. The value of f of x at 1.5 is 19.25. Applying this, the formula for BDD, we have f of x, f prime of x is equals to 27 minus 19.5 and roll over our step size, which is 0.5. So we have a value of 15.5 for BDD. So now let's solve the value of our slope at point 2 in CDD, or center divided difference. Since we get the value of xi minus 1 and xi plus 1, we will directly substitute those values, these values and these values, to our equation for CDD. So our f of x prime is equals to 36.25 minus 19.25 all over 2h. Our h is 0.5, so 2 times 0.5, and we have a value of f of x prime at point 2 of a value of 17. And take note, the actual value of our slope at point 2 is equals to 17. Comparing this value FDD to the true value, there is a 1.5 difference, and for our CDD, there's also negative 1.5 difference. As for CDD, we have the same result for our actual value. So in short, CDD has always more accurate value than BDD and CDD. So it's relative better to use CDD when calculating the value of our slope in a certain point. So that's all for these topics.